Today what we're going to do is we're going to still look at applying properties of positive and negative exponents, but we're going to look at scientific notation. Now you've had scientific notation before, so I look for this to be a really easy section that you can just kind of pluck right through it, no big deal. Okay. If you didn't understand it when you did it in science, that's okay. Hopefully you'll learn it this time. All right, so my question is, why do we study scientific notation? Why? It's decimals, so we can write large numbers, so we can write really small numbers, right? And where do we use it besides math class and science class? English. You could see it in English. You could. You can see it in art. Shop class, science. You can see it in Phi-Ed. Cars. Where in cars? The miles. Okay, the miles. Yep. You can kind of sometimes see that. You can see it in the newspaper. Or in the news. They talk about, you know, how many million light years away it is or whatever, you know. Astronomy, we see it a lot. So we use it when we see really, really large or really, really small numbers. All right. So when we see scientific notation, you're going to see a number, and then it's going to be an X, which means times. Don't use a decimal there. Make sure you use an X. And it's always 10, and it's to whatever number. So that's kind of the form that we see it in. So let's take a look at this first problem. What we're going to do is you put the decimal behind the first non-zero number. So do you notice how 4 is the first non-zero number? So I'm going to write it as 4 point. It's always behind the first non-zero digit. And then I'm going to write the other numbers behind it. 2, 5, 9. But I'm going to stop at the 9. I don't need all those zeros. So I'm going to chop them off and throw them away. I don't need them. But you have to include all the numbers up to the very end of those zeros. Okay? And then I'm going to go times, no, it's an X, to the 10th. And I'm going to stop you right there. You always set it up that way. All right, now I've got this really, really large number, right? Where is the decimal in the first number right here? Well, it is on the right, but on the left, it's right here, isn't it? Okay? And I want it behind the 4. So I'm going to go 1, 2, 3, 4, 5, 6, 7, right? So I moved it 7 places. So it's going to be times 10 to the 7th, and I'm done. Kind of coming back from science class. All right. Let's go to the next one. All right. What is the first non-zero digit on this one? 2. So it's going to be 2.765. And the rest are zeros, so I'm going to chop them off. I don't need them. And then I'm going to look at how many decimal places. So there, the decimal was here. And I'm going 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's times 10 to the 8th. And I'm done. We okay? Yep. It's always going to be a 10? Yes, it's always times 10. That's what moves the, all you're doing is moving that decimal back and forth. That's all you're doing. We okay? All right. Let's go to the next one. Now, do you notice that number 1 and number 2 are really, really big numbers? Yes? Yeah. Number 3 is a really, really small number. Okay? So that's going to go equals, and it's behind the first non-zero number. So what is that number? 5. So I'm going to go 5.74 times 10. Right? And I have the decimal right behind there, right? And I'm going to move it 1, 2, 3, 4, 5. Yes? Now, because it was a really, really small number, we're going to make it a negative. We okay? So I put it behind the first non-zero digit, put the decimal, and count how many decimal places I moved it. And because it was a really small number, it's going to be a negative number. Okay? The exponent. All right. Do this one by yourself for just a minute. Okay? I'm going to write what? 4.86 times 10, all right? And then it's going to be to the negative 4. Let's count it. I've got 1, 2, 3, sure enough, to the negative 4. And I'm done. Questions? How come you two need to flip-flop? Flip-flop. I know it was yesterday, too. Yeah.
Hey, I didn't even switch. It was her.
Mm-hmm.
I'm not kidding.
Mm-hmm. Right, so notice that this is scientific notation. Now we're going to do standard notation. Right? This is a way to take a number that's in scientific notation and write it in a longer form. So here's my scientific notation. And what I'm going to do is this. So I've got 2.0075, right? And I'm going to move it how many decimal places? 7. So I've got it here, and I'm going to move it 1, 2, 3, 4, 5, 6, 7. And what do I put in those blank spots? Zeros. So then what I'm going to do is I'm going to rewrite it because I don't want to just leave it like this. I'm going to go equals 20075,000, and I'm going to put commas in there. So it's 20,075,000. Okay, and the reason why I rewrote it is because do you notice the one that I have underneath it? I've got 2 decimal places. I don't want 2 decimal points in a number. That doesn't make any sense. Okay. So you want to make sure that it's written with the commas. All right, let's go to the next one. All right, it was 7.0234, and it's to the 5th power, right? Times 10. So I'm going to move it 1, 2, 3, 4, 5, and I put in a 0. So I end up with 702,340. How do I say that number? Not 700 and 702,340, not 340. It's 340. When I say and, what should go in my number? The decimal. Yeah, so you have to be careful not to throw an and in there. So this is 702,340. Okay. All right, now look at 3. Did my number get bigger or smaller? It got smaller. So this looks a little bit different. So I've got 3.0996, and I'm going to move it to the left. To the left. Yeah, right. So 1, 2, 3, 4, 5, 6, right? And what do I put in those little spots? Zeros. So my number ends up being 0.00003096. And I do like to put a 0 in front of the decimal because a lot of times you see it that way. We okay? Do you remember doing this in science? I heard you did it a lot this year.
Yeah, I never got it.
But you get it now. Sweet. It's awesome. All right. I got 1 1.685. And is it going to get bigger or smaller? It's going to get smaller. Okay, so we're moving it to the left, right? Here we go. 1, 2, 3, 4. So 0.0. Excellent. Right there. We okay? Good. So like I said, if you didn't get it in science, hopefully you get it now. If you still don't get it now, no, don't be dumb. Ask questions, right? Yeah, we want you to be smart. So you got to ask questions, and I'll go over it with you again. Okay. All right, here we go. One last slide. We're going to compare. Now, when we compare these, we want to line up our decimals, and we want it in standard form. So which one of these is in standard form, the first number or the second number? The first number. So I'm going to write that down over here. But do you notice that the second number is not in standard form? So we need to get it that way. So I'm going to move the decimal 5 units to the right, okay? Yeah, to the right. Here we go. So 1, 2, 3, 4, 5. So I got to line up my decimals. Now you check and see which numbers are the same. See the 4s are the same? And then the 0s? So you go from left to right. Do you see how these two numbers are different? Yeah. So which number is bigger, the top one or the bottom one? The top one. So I'm going to use my greater than sign. So you need to put it in standard form. Don't just give me a sign. It drives me crazy. I want you to make sure that you use that standard form, line up your decimals, and compare. Because they're going to throw tricks at you is what they're going to do. All right, let's do the last one. Is the first one or second one in standard form? First one. So 0.003309. All right, and then I got this number, and I move it 3 spots to the left. So 1, 2, 3. Yeah, to the left. Right. 0.003309. Which one's bigger? They're the same, so I put in an equal sign. Okay? All right. Here's your love for the day. The love of knowledge. Yep. I'm giving your brains a hug. Right. Page 515. You're going to do 3 through 27 odd and 33 to 47 odd. Okay, so we're going to open up your books. I'm going to do the first one with you because a lot of students had trouble with that. And then what I'm going to do is I'm going to do the last couple of them with you because, like I said, last hour I had a lot of students that had trouble. So I want to make sure that you understand it.